This is solution 2 to problem 25 from the AMC 12B from 2022. So we know that this is an odd shape, oddly looking shape, but we know that all these edges are straight, so they're perpendicular to each other. So all we can do is, if we just make this thing a big square, that would make it a lot easier for us to do the math, you know. So we do that. And then, well, all these aren't even triangles. They're weirdly shaped, four-sided shapes. So if we can just divide it into two triangles, like so, for each corner, that would be very simplistic. So we've basically made our whole shape a giant square. And well, now this can be basically a pi problem, where you have the total area of this big square and then subtract all these missing parts, correct? Okay, so I might have made a mistake in the last video, or in the last solution, but this whole length of the hexagon is the square root of 3. So basically, if one length of the hexagon, one height of the hexagon is the square root of 3, well, this whole length will be, well, 2 times the square root of 3, but you're over counting something, this square in the middle, so this height is 2 times the square root of 3 minus 1. Okay, so that means that this height here is the square root of 3 minus 1. I should write that. The height is the square root of 3 minus 1. Or no, because we already know that. Alright, so we have this, and now we want to find the area of this octagon and then subtract the area of these smaller triangles from the big area of the octagon. So if we have all of these 4 triangles, well, what's the height of this? This is going to be the square root of 3 minus 1. And since these lengths are going to be equal, and we know it's the side length square root of 3 minus 1 because of, we can say that, hey, if this whole height of the hexagon is the square root of 3, you're overcounting this part, and so you subtract 1 here. And why this makes sense is because these lengths are equal. So that's how it aligns, square root of 3 minus 1. So we have the area of the octagon, which is 2 times the square root of 3 minus 1 squared minus 4 of these little triangles is the area of the octagon. So 2 times the square root of 3 minus 1, it's the big area squared. And then you subtract 4 times square root of 3 minus 1 squared over 2. Alright, now this basically evaluates just all the way down to 5 because these square roots can multiply out. So now we can do 5 minus the area of these 4 small triangles. This might seem a bit hard, but we know the base length because we can use Pythagorean's theorem, because we know these 2 legs. So we know that the base length is equal to, well, when you solve it, that's just square root of 3 minus 1 squared times 2, correct? So the base length is just, this is square root of 3 minus 1 times the square root of 2, or squared times 2. Okay, so we know that the area of a triangle in this case is 1/2 times the base length times the tangent of this of that side length. So we know the base length, correct? Our base length is simply going to be 1/2 times what? The square root 3 minus 1 times the square root of 2 squared, and then you multiply it by, well, the formula states that it's the tangent of 15. This multiplies out to 1/2 times 4 minus 2 root 3 times 2 minus square root of 3, which equates to 7 minus the square root of 4 root 3. Now our total area is going to be 5 minus times that. So we can do that real quick. So this is 5 minus the 5 minus 4 times 7 minus 4 root 3. This is going to yield our same answer, 16 root 3 minus 23. So summing all those up again, we get our answers -4, just like in the previous solution.